Hey, you're back for some more right angle trigonometry using your friend Chief Sokotoa. So you need that memorized? You've got that memorized. So what we're doing in this video is finding a missing angle in a triangle, specifically a right triangle. In the previous video, in the previous problems you did, you found a missing side length. So let's take a look at examples of finding a missing angle. It's going to go faster for you now that you're a veteran of this. Okay, so I look at this triangle and I notice I know two sides, so I could use Pythagorean theorem to get this side, but that's not what I want to do. I want to find out how many degrees is that angle. Okay, well, I take a look at the situation. I know something about the hypotenuse, and I've identified this as the adjacent side because this is the opposite side over here. So I know something about the hypotenuse and the adjacent. So if I think about this, that's a cosine, because cosine is adjacent over hypotenuse. Cosine is my trig function I'm going to use. So I write this out as a first step always. Then I replace with what I know. I know the adjacent and the hypotenuse lengths. And I'm trying to solve for theta. And you've never done something like that before, so let's take a look at what happens. I take this 10/16 and I do division. That's basically 10 divided by 16. But now to get this cosine out of there and just have theta all by itself, I have to find the enemy of cosine. In all your algebra moves, you're always doing the opposite to get rid of something. We do the opposite of division as multiplication to get rid of things in an equation. The opposite of addition is subtraction. Well, the opposite of cosine is oddly called inverse cosine. So where are you going to find inverse cosine? If you go back to Desmos or your calculator, you're now familiar with the sine, cosine, and tangent keys, but you also have inverse sine, inverse cosine, and inverse tangent. That little seems like an exponent of -1 is just a symbolism for inverse. So it's the same thing as before. You would click on the one that you wanted. In this case, I'd probably want inverse cosine. Type in the value, and it'll spit out a degrees. So what I really did is, in this case, on this side, the inverse cosine and the cosine fight to the death, and I'm just left with that. Over here, I need to turn this into a number, that's 51.3 degrees. That's what I was doing on Desmos right here, or on your calculator. So realize that basically this new move for you is I need to get rid of cosine to get this by itself. The enemy of cosine is inverse cosine. If I do something to the left side, I must also do it to the right side. So that's why that's over there. And this awkward thing turns into a value that's 51.3 degrees. So I now know that angle is 51.3 degrees. One more example, and I think you would understand this totally. Here I have a right triangle. Trigonometry, the way we're using it right now, only works with right triangles. I know some information about the opposite side. And this is the hypotenuse. I don't know any information about the hypotenuse. That would make the 18 the adjacent. So I know something about the opposite and the adjacent. Opposite and adjacent, according to Chief Sokotoa, uses tangent. Here we go. Write out the basic relationship. Replace with some values. Turn those values into a decimal. Now you say I need to get rid of the tangent so that the angle symbol, theta, is by itself. I kill the tangent with the inverse tangent. If I do something to the left side, I have to do it to the right side because the world is fair, and algebra is definitely fair. Now I get theta by itself. I use Desmos or my calculator to use inverse tangent to turn that into degrees. I now know that this angle is 21.3 degrees. Short and sweet, like a tweet.